All right, so let us go through the homework from Indices. So this is what we finished with last time. Gave all of these questions. Each of them came with an answer. The answer linked to a letter. The letter then had to be put in the correct order in the bottom. Did you guys end up doing this and getting an answer for why didn't the number 4 get into nightclub? So Larissa, what did you get? Exactly right. Exactly right. Well done. All right, so these are the letters that corresponded to each of your answers. And once you put them into the bottom row, you came out with the fact that he did not get into the nightclub because he looked too square. And that is a pun on the word two, since 4 is 2 squared. All right. Any questions from this homework? Jean-Yves, anything from you? I will take the silence as a no. All right. So that's great. So let us move on to no problem. With your computer being slow and all, did you have any questions? Okay, great. I'm glad everyone understood. So, the Pythagorean Theorem. So, I will refer to this as either Pythag or Pythagoras. Pythagoras was the Greek mathematician that actually discovered this theorem and formalized it. And it says that if you have a right angle triangle, I think I might have one. No, I don't. Oh, well. If I have a right angle triangle, and it is specifically for right angle triangles, I know that if I have this length, I'm going to call this length y. In other words, that distance of my vertical side. And this distance, let's call it x. It states that the sum of the squares of the two legs, not leagues, legs, equals the square of the hypotenuse. So in case you have never heard of this word before, hypotenuse means the longest side of a right angle triangle. And this longest side will always be opposite my right angle. Therefore, this is my hypotenuse. And often the hypotenuse is denoted with the letter R. So it says the sum of the squares of the two legs. So if it's not a hypotenuse, it is known as a leg. So therefore, x squared plus y squared equals the sum equals the square of the hypotenuse, r squared. Well, that's nice. Formula is not too complicated. I can understand that I'm squaring that side plus that side squared equals that side squared. What's so hard about this? Well, there's nothing entirely hard about it, but unfortunately, this doesn't really actually tell you what the theorem is actually telling you. Because when you square something, what are you actually doing? Well, when you square it, you are actually creating area. So I'm taking this length of y, and I'm creating a square where all sides are length y. This area is y squared. Just as over here with x, orange is too close, light green. If that side is x, that side is x, that side is x, that side is x, and this whole area here is x squared. Because remember, area of a rectangle or a square is length times breadth. Length is x, breadth is x, x times x is x squared. So in actual fact, we are adding areas together. And these two areas will equal the area generated by my hypotenuse. And this area is r squared, because that length is r, 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 and r. So that's quite interesting. I'm sure that you probably didn't gather that we were actually dealing with areas. So on YouTube, there is a wonderful little demonstration of this. So I'm going to reshare this demonstration. There we go. So here you see you have your right angle triangle. There's the symbol for your right angle. And what they have done is they have added liquid into this square. And you can see that this is a square of that side. And added liquid into this square, and that is the square of that side. And they've put little holes in either side. So the water's running down there, the water's running down there. And therefore the area of that plus that is now this one. Just to show that there's no trick, they turn it around again. And there it comes back to the individual two. That is what Pythagoras is actually about. It's amazing. It is absolutely amazing. Have you guys ever seen that sort of idea of Pythagoras before? If you're interested, Pythagoras in your notes is week 11, lesson 38. All right. So with Pythagoras, you can do a whole bunch of things. And it's also useful to know about the Pythagorean triples. Now, what is a Pythagorean triple? Well, I'm going to give you 3 right-angled triangles to demonstrate this. This one is going to have 6. It is going to have 10, and I need to solve that. This one is going to have 4, 5, and an unknown over there. And then let's do unknown over there and 5. All right, 3 triangles. I have an unknown hypotenuse, I have an unknown leg, I have the unknown other leg. Pythagoras says that r squared equals x squared plus y squared. So it's 6 squared plus 10 squared. Well, 6 squared is 36. 10 squared is 100. So that is 136. So how do we get r by itself? Well, you need to square root and square root here. So r is a square root of 136. But 136 is not a square number. So I know that 121, the square root is 11, and 144, the square root is 12. 136, somewhere in between. So we can actually go to our calculators even and calculate this. So we have square root, just bringing my calculator up. So I want 136, and I square root it, 11.66. Round it off to 2 decimal places. But that's not a nice number. What about if I have a look at this one? So this one here, r squared is x squared plus y squared. My r is my 5. So 5 squared equals my x. I'm going to let that be the bottom one. So my unknown is x squared. And then I have 4 squared for my y. 25 is 5 squared. 16 is 4 squared. Take the 16 over, and when I take it over, it becomes a minus. So that becomes 25 minus 16 is 9. How do I get x by itself? I square root. And that leaves me with x being 3. Well, that's a nice number. And yes, I know that if you square root, it should be a plus minus, but we're dealing with sides of a triangle. Sides of a triangle can never be negative. So I know it has to be a positive answer. So this is actually equal to 3. First Pythagorean triple. And a Pythagorean triple means that it's a right-angled triangle where all 3 sides are nice whole numbers. So this is known as a 3, 4, 5 triangle, where the last number is always my hypotenuse. So the 3 and the 4 legs, they can swap around. They can be on either side. It doesn't matter, as long as 5 is on the hypotenuse. That also means that any multiple of a 3, 4, 5 triangle will also be a Pythagorean triple. So if I have, for example, 6 and 8 as legs, notice I'm doubling 3, I'm doubling 4, I will automatically know, without having to calculate Pythagoras, that my hypotenuse will be 10 because it's double 5. So any multiple of 3, 4, 5, and you'd be amazed how many times you see a multiple of this. If I times it by 3, a 9, a 12, and therefore a 15 triangle will follow Pythagoras' rule. All right, let's have a look at this one. All right, so you've got 13, 5, 13 hypotenuse, unknown leg. So my hypotenuse is 13. Again, for consistency, I'll use this flat side as x. So therefore, that's 5 squared plus y squared. 13 squared, 169. 5 squared is 25. Take the 25 over, so it becomes a minus. 169 minus 25 gives me 144. And then I've got a square root, and I've got a square root. And then when I square root, I'm left with the square root of 144, which is 12. Well, that's interesting, because that means, therefore, here, that this is another Pythagorean triple. So we have a 5, 12, 13 triangle, where 13 is my hypotenuse. And again, any multiple of 5, 12, and 13 will be a Pythagorean triple. So if I double it, I get a 10 and a 24. I will know that 26 will be my hypotenuse. If I multiply by 3, I get 15. And let's say I know that my hypotenuse is 39. Therefore, I will automatically know that the other leg must be 36 without having to calculate everything. Very useful. Very, very useful. All right. And this is the key with Pythagoras, is you will either be given two sides and calculate the hypotenuse, as I did here, or you'll be given the hypotenuse and one side, like these two questions, and then you'll have to find another side. Please note, I specifically chose these two so that the answers would be nice. It does not mean that every time you are given a hypotenuse and a side, the other one will be nice. There are far more times when you'll end up with a nasty square root that doesn't simplify than when you don't. All right. So the work for this, if you want to have a look in the textbook, is in your book 3 under chapter 10. And it is all the same, finding the hypotenuse, finding the side length, and all of these calculations. Any questions? All right, so once again, remember this is week 11, lesson 38. Whether you have or haven't got into it yet, that's nice. You at least have been taught it now, or I've revised it with you. And this really is free marks when you come to it in a paper. So please make sure you write it. And the last thing that I need to make sure to tell you, and I have actually been slack about it for this whole lesson, which is terrible, is whenever you write down the fact that you've used Pythagoras, you have to write down a reason, because this is part of your geometry section. And in geometry, you always have a statement and a reason. So always write down the reason. You can write Pythag. You don't have to write Pythagorean Theorem. You don't have to write Pythag Triple. You just have to write Pythag. 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 Pythag is the acceptable abbreviation for the reason you need to give. All right.